get some of my things here, and I'm going to ask Robin Locke to come up. Robin has been traveling the country far and wide to do just the kind of thing that we're trying to do at this conference, and that is to introduce and to further folks' understanding and knowledge of the teaching of statistics. As I understand it, Robin didn't pursue statistics when he was teaching from an early age, but kind of happened onto it, as it seems like so many of us have done. Happened onto it later in life himself as a graduate student. I'm kind of interested with Robin, as with a number of our speakers, those who are teaching faculty. What is it you find so interesting and so important about the teaching of statistics? I have a feeling that's going to come out in their talks, but in case it doesn't, it's something I'm going to be one to ask. And so Robin is going to begin our conference and going to end our conference. Today he's going to tell us where we've been and where we are, and tomorrow he's going to tell us where we're going. And so without further ado, I'm pleased to ask you to welcome to our conference Robin Locke.
Still up there, everybody? I'm probably going to stand right about here, and that's projected right about there. So if anyone wants to rearrange, feel free to do so. And there are seats in the front, as always, if people need them. Okay, well, first of all, I really want to thank Bob and the steering committee for inviting me this year. I've had other commitments in June on the first two sessions of these and was unable to come to these, and I really wanted to come to both of those. So I'm excited we moved it to August this year so I could make it to come, because I've heard these have been really fun things to go to. And so I think I'm supposed to start off talking about how technology has changed the teaching of statistics. As I go along here, a couple things to note. First of all, feel free to interrupt, stick your hand up, comment, disagree, whatever. I tell my students that because the pattern in class is if everyone's sort of quiet and sitting there, then I figure, well, I can go faster. And if they're quiet and sit, I go even faster. And pretty soon, you know, we're ready at 10 o'clock for coffee. And so feel free to slow me down and stop and ask a question or especially make a comment as we go along. Also, somewhere up here, and they've disappeared, they were up here. It's over there. They grab these. Oh, that's okay. No, I've got copies of everything that's going to appear up here. But I'll keep these until I'm done, so that way you don't start. But that does mean that you don't need to take notes. You don't need to be in active listening mode. You can do the other things that Dean is referring to. But there is copies. Actually, there's copies of all but one. There's one I added on this morning, and so your challenge is to pay enough attention so that when you see this, you can say, that's the one that wasn't on there. And see if you can figure out. There's 25 slides here. There's only 24 on the sheet here. So your challenge is to see if you can find the one that's missing. Okay, well, the approach when Bob asked me about doing this, so we want to talk about the introductory applied statistics course. And what I decided to do was to look at 1983 was when I started teaching at St. Lawrence, and that was the first year I taught introductory statistics. I had taught it some as a graduate student and some at Clarkson University before I saw the light and went to St. Lawrence. And so I want to look at this, and I went back to the fall of 1983 versus the fall of 1998. I figured we'd keep the fall part constant, so we don't have very influencing things. And it also gives the impression that I actually started thinking about this long ago. In the fall of 98. But sort of try to compare what my course looked like between 1983 and 1998. Just for a little background, St. Lawrence University, where I teach, is a small private liberal arts college, slightly under 2,000 students. The introductory applied statistics course is a general course for everyone. It's the only 100-level stat course. It's the only intro-level stat course on campus. So the idea is people come and take our intro stat course. We have everybody in there. and then they can go off and take specialized courses in psychology or economics or whatever after that. But we're sort of have a general stat course for almost everybody. Not much specialization at all, which makes sense at a college like ours. Okay, so how have things changed? Well, I look back, and this is a little hard to see, but I actually had a quiz that I gave in 1983. If anyone's ever been to St. Lawrence to see my office, they know why I still have quizzes from sitting there. In fact, I've decided what I'm going to do is every year get a chair that's a little bit higher. So I can just get up and bump my desk, and I know Kelly's been there. Kelly's seen my office, and she can vouch for that. Anyway, this is a quiz in 1983. If you can't see, it's a little hard to see there. This is quiz 3, September 22nd. Math 113 is the number for the course. You see that. And I thought this is just sort of a good way of seeing, since quizzes and exams are often how our students view the course. That's sort of a good place to start anyway. A couple of things you notice here. The first question says, assume we have a sample of n equals 9 Labor Day temperatures in degrees Celsius, and then it gives the 9 temperatures, compute the sample mean, compute the sample variance, and the standard deviation. Fairly routine sort of question. A couple of things to notice about that. One is the fact that we put them in Celsius so that when you square them and have people, you don't get it quite as big as you get Fahrenheit, right? So it's a little bit smaller numbers. There's only 9. There's not much recognition of where these numbers come from. The other thing to notice, just in terms of looks of it, though, this is handwritten. Okay, this was back when I actually could write by hand. I can't anymore. I can get about the first 2 letters of my name when I sign something. That's about it. And you also notice that nice kind of blue color. From the days when you can get your quiz. Right? That's one of the things we've lost in technology. We don't have the machines to do that again. So certain things have changed, not always for the better. But I mean, a lot of things have changed. It just made our job, in some cases, easier, in some ways harder. Here's the equivalent quiz. It's kind of interesting. This was a quiz where the first data set happened to be temperatures. And in the fall of '98, you can see I haven't changed anything at all. It's a data set on temperatures, which was kind of interesting. And I went back to the same one. It often happens that there's some sort of heat wave at the beginning, so some students are interested. Well, you know what's the difference now? Right? It's typed, right? Assuming you have really good eyes, you could read it. But it's so it's a lot clearer that way. There's not 9 data points. Now there's 33. Okay. This little note up here says data below were obtained from the U.S. Weather Service's website, and there's the web address. Okay, and this was 2 days before the quiz. So this is current data. It came right off the web. Okay, and they've got the address of the country. So certainly in terms of realism, there's a big improvement over here. Is 9 temperatures from some Labor Day. I mean, this is real data. I didn't have to work very hard because I could just pull that data off the web and dump it right into a word processor, into my stat package, and decided to order it by high temperatures. That was all done automatically. And then the questions now are to do a 5-number summary instead of the mean and the standard deviation. It's a reasonable thing to do. And then the second question here is, are there any high temperatures which we classified as outliers? Show calculus. So there's a little bit more conceptual working with that data rather than just saying find the mean and find the standard deviation in terms of that question. And it is slightly more readable than the data I had before. So that sort of captures a lot of things that are different just by looking at those quizzes. Okay, so what's new? What's in my course now that wasn't in the course in 1983? Okay, and some of these things are due to technology and some are just due to other changes. And Bob finally got in here and played yesterday and had sounds, and Bob said, put some sounds in. So we got to play the sounds. A lot more plots. Okay, in 1983, no stem plots, no box plots, no dot plots. Okay, a lot more plots now because the computer does this for you very easily. So a lot more in that sort of exploratory, let's look at your data type stage of the course. Side-by-side plots. Never saw those in 1983. But now it's real easy to look at temperatures for western cities and temperatures for eastern cities and do a side-by-side box plot or something like that. Those sort of comparisons are real good early on to hook students on comparisons. Okay. Another change is early two-way tables. Okay, that's when the course has changed. I'll do two-way tables real early in the course. I'll talk about that a little bit more. I'll talk about what's happened to probability. Early correlation and regression. In the old days, that was kind of like the last 1 or 2 weeks of the semester. Right now, right away, early on in the first couple weeks of the semester, they'll do some correlation and regression as they go along. Added sections on experimental design and sampling. Those weren't in the early course at all. We didn't worry about where the data comes from. Someone gives you the data, and now you go off and do things with it. We never worried too much about where the data comes from. Jason's grinning over here because Jason spends all his time worrying about where the data comes from. But that's something we've added, and that is the technological advances have let us get a little more room to do some of those sorts of things. An early descriptive project. Okay, in the old days, it kind of one big project at the end of the semester. Now I've broken up and I have several different projects as they go along. They'll somewhere in the first, probably be assigned the second or third week of the semester, have a project where they just have to collect some data and describe it. Descriptive statistics and lots of graphs. Something I couldn't have done in 1983, but get students going on looking at their own data very early now. So that's a thing that's been added. Another thing that's been added, as kind of mentioned, is p-values. Right? 1983, we never mentioned p-values because it's too hard to compute them. Right? Now, p-values are the way we go about hypothesis testing. The old critical value approach is not something we mentioned that sort of in passing, but p-values is really the way we do that. Okay. Well, if all that stuff is new, something's got to have gone. Right? This is a lot of where the controversy that comes when you reform something is what goes. And it's surprising that actually in statistics, I've found that there's less controversy about what should be taken out. My wife does a lot of stuff with calculus reform. And anyone involved with calculus reform know there's tremendous controversies about what you have to take out in order to put in these new things. The statistics community, in my sense, has been a little bit better on that. So things that have gone. Non-parametric tests. Okay, no more. And that's kind of a shame. I think that's one thing that may come back a little bit. But that certainly gave some room for things. Right? Bayes' rule.
Okay, the same question.
Yeah.
Why is that a shame? Non-parametric.
Because I think in some cases the non-parametric tests are not a lot worse to do than the parametric tests, especially when you've got the computing power to do them. In the old days where you had to have a different table for here's your Mann-Whitney U table and here's your rank correlation table and here's a different table, it really was pretty cumbersome. But now that you've got software which does that pretty efficiently, they're not necessarily a lot different to do than the parametric tests. And also we find a lot of students, once they get done, will go out some places and will encounter those. They'll write that article and someone will say, well, no, did you check this assumption? You should use non-parametric alternatives. So that's something that may come back in. I don't know. Bayes' rule, I love Bayes' rule, all those questions about, if you prick yourself for TB, you really have it, those sort of things. They're great problems, but that's gone. So these aren't necessarily things I didn't like doing, but I think they really aren't necessarily in the realm of applied statistics. Permutations and combinations. That's one of the ones, we used to do that early in the course. You want to turn people off early in the course through permutations and combinations. Probabilities of unions and intersections, they're gone. The shortcut for calculating the sample variance and sample correlation, that's out. What else? StatPack, that was a stat package. We actually did use a stat package back in 1983. It was on the mainframe. Okay, you kind of had to enter the data each time you wanted to analyze it. Didn't have any facilities for saving that. There was no place to save your data. You had to put it in, do your analysis real fast before it went away. And it was really a real clunker. So that's gone. And that's a good thing. Mainframe stat packages. I don't know where to go. The F-test compare variances. That's gone. Discrete probability functions. These are things that have left more recently. So nothing with discrete probability functions. No computing expectations from probability functions. Normal approximations to the binomial. That's gone. Probably a good thing because the binomial random variable is now gone. And I'm going to get some more kind of, that was one of the last ones I got to leave, but my wife, who teaches a stat course sometimes, says, why bother? And so we don't cover the binomial random variable anymore. And that may be starting to get more controversial for some people to leave that out. Okay. What else is new? Minitab. Okay. Tina will be happy here. Minitab is our package of choice now, although there are certainly other good possibilities for that. So that's our new stat package. We do lots more with simulations of sampling distributions. That comes along. I'll talk some about that. Videos. So you've seen the Against All Odds video series. It's been around for quite a while now. But we use that. We actually have every Monday and Thursday evening is Stat TV night. on Channel 8 and St. Lawrence TV network. You can watch stat videos, which are key to the intro stat course. I don't think we're quite there on ratings with Monday Night Football yet. I think probably the students tape it while they're watching Monday Night Football so they can watch it later. But we do have a couple of evenings a week where students can watch videos, and that's a good series. Data from the web. Okay, that's certainly a big thing, and I know David's going to talk some about that. Is that tomorrow? You doing that? Going to talk about data from the web. That's certainly a big new thing. And Java applets. That's another new thing in our course. We sort of snuck one of those, and we're fortunate to have, I think, one of the world's most creative stat Java applet person in Gary here, who's going to show us some things later on. And there's just amazing things out there that people have done with Java applets. So that's a new thing that's been added to the course. Okay, new technology. What's letting us do all these things? Okay, classroom projection facilities. Okay, that's a big change, and we go along. And I know I had some fights for that back in the early days when we were using the stat pack, and I wanted to show my students how it worked. And so what I would do is run on the mainframe, print what was going on, put it on overheads, and then go in class and go through the overheads. Right? And I know my dean's saying, "Well, what do you need a projection system for? You can just do that." Okay, which isn't very good when some student says, "Well, what if something else happens?" I mean, it's just so static and things that all our classrooms that are teaching now have some sort of projection system like this, which is really important. Okay, campus computer network. Okay, that's made my life a lot easier to have. Our school is set up so that every dorm room, every classroom are all hooked into the same network. So everything they see is in class is just like they see in the labs, is just like they see in their dorm rooms. And so that makes it a lot easier for them to have some consistent interface and to distribute software. Related to that, class directories. Okay, it's really nice now that I can have a class directory for each of my courses. There's a Math 113 directory on the network. All my data sets, I can sit in my office and say, I'm going to use this data set tomorrow in class, load it on there, and then the students automatically have access to that from anywhere on campus by just going to that directory. Email. Just curious, how many of you have students send you email with questions and things? That's going to be a fairly common thing. It's a whole lot better for me than phone calls because then I can actually have to think about the response sometimes, which needs doing. But also it's a lot easier for students because it's 2 in the morning is when I'm getting these emails. And I'm not going to be there for calls in anyway. So that's been a big help. Computer classroom. Okay, and I guess we're going to get to see some of the computer labs here. That's one of the things actually we'll see. Here's our current computer classroom. It's a real nice setup. They had our old science library, which was hooked up to the next to the math department. That they moved the old science library out, had this space available, and so the biology department and sucked up all but one little room. They managed to carve out this one room that we could put a computer classroom in. And if you see here, the way it's set up is that the computers are all down below the desks. The monitors are all sitting in at below desk level, and there's nice glass tops. So it's a great room for teaching because I can sit up there and I can see all the students, and they can see me. But then they can get at the computer anytime they want. Plus, there's nice big desks and stuff, so it's really a nice room of teaching.
We looked at that, and we had to put a hood over to keep the light reflecting off the
Yeah,
glass.
it depends. In fact, there is a hood. I think you see. There's a hood sitting right there. So those often are floating around. It depends upon where they sit and whether they need them. Unfortunately, this room only has 24 stations, and usually my stat class gets bigger than that. So the intro stat class, I can't meet in there as often as I would like to. I've gotten as many as 25 students. I used to use airplane seating when I do have a stat class in there and figure I can register 26 students, and there'll always be a couple of them that aren't there on a particular day. And so we can usually do okay. But especially for the upper level courses, that's a great room to teach in. They're building another one of these for us this summer, so we'll have a second alternative to use there. Okay, what other technology do we have? Statistical software packages. That's changed a whole lot since 1983 in terms of capabilities of those sorts of things. One of the things I'll talk about some in a session later today is the way you might go about evaluating software packages and seeing what things you'd like your package to do. Other support software, just word processing, other type things. makes life a lot easier. Statistics calculators. Fred's going to talk about the TI-83. Other sorts of statistics calculators that are around there are a lot different now in terms of the capabilities. I mean, the TI-83 does most of the things you need to do for an intro course. Maybe not as conveniently in some cases as Minitab, but you can carry it around with you and go. Okay. Fast web connections. In the early days of the web, you worried about would it be there at all, or would you have to wait and wait and wait and wait for graphic to come in? And things have just gotten a lot faster. We still really can't do real-time video real well, but most web stuff we can pull in class without worrying about connection times too much. And things like course web pages. This is something I'm just getting started on a little bit. I know some people here have got much more elaborate course web pages. But I've just got a very small, fairly simple-minded course web page where I've got links to various applets that my students use at various times, just so they don't have to type in that big URL and use that. So there's not a lot of stuff there. I know some people have much more extensive course web pages. That's one of the things I'll talk about tomorrow. When we talk about web resources, I'll show you some places where people have really nice, very elaborate course web pages that they use. Okay, got to talk. You had that sneak back in there. Let me see, can I go back here? So there's the back one. Did I just have binomial there? That must have been a recent, what do we got there? Yeah, but does that say binomial anyplace? Oh yeah, it's in parentheses. I was in parentheses, that doesn't count. We talk about count. Yeah. No, we do talk about count data. We do talk about proportions and how the proportion comes along there. Yeah. But I don't actually talk about a binomial and a variable and binomial probability function and that sort of thing. So yeah, certainly we do count data. So we haven't lost it quite that much. So I guess that's the remnant binomial that's still sitting there in the course. All right, I tend to be fairly positive about technology type things, but I do have to throw in a couple concerns because I know everything isn't really good. So one of the big issues is it's hard to keep up with new technology. I can't keep up with everything I'd like to keep up with. I'm sure none of you can keep up with everything you'd like to keep up with. Things come along, and I find myself now when I look at between new versions of my textbook, new versions of the software, new versions of the campus network. I mean, our course has got to be redesigned every single year because nothing's ever the same as it was the year before. Okay? And so that's an issue in trying to keep up with all this new technology that comes along. And that's a hard thing to do. Technology can be expensive. Right? This was more of an issue in say the late 80s, less so now. There's lots of, you can get the money from a lot of schools to build the computer labs, to pay for software and that sort of thing. And certainly if you look at your software budget in the university from 1983 versus 1998, I'm sure there's a considerable difference in how well that's accepted to do that. In my particular case, it's interesting that CalPerform has helped drive that a lot. Because as soon as all the mathematicians got on board to say we need computer lab to teach calculus, then hey, the statisticians can go and teach them there too. That funded a lot of the lab work. Okay, what else? An important concern is teaching statistics and not technology. I think George may talk some about that once he makes it back from Niagara Falls this evening. Because that's an issue. It gets real easy when you get caught up in the technology to spend more time worrying about that and to lose sight of the statistics you're trying to teach along the way. I think back to many years ago when I knew a colleague who was very excited because he was having all of his students program all the formulas in BASIC. He just thought that was a wonderful thing to do. And they probably knew those formulas real well, but they probably didn't learn a whole lot of statistics from doing that. And so I think that's one thing we have to be careful of as we get zooming along in technology, to not lose sight of the fact that we're trying to really teach statistics. Okay, and as always, although we haven't quite hit these yet today, but there will be, things will fail. The most reliable teaching instrument I've ever known is that piece of chalk. It breaks, but it still keeps on working even after it breaks. That certainly doesn't work for technology. And all you need to do is to plan to give an exam where the data is online, and they're going to access that during the exam online, and then have the network crash or something as you go along, and you know you're in trouble. But we've all experienced that. Okay, one thing that I think that counterbalances a lot of the concerns, and I mentioned to see whether people also find this. Students know a whole lot today. I mean, I'm thinking back to the days when you had to explain what a disk is and how it goes in the machine and where you get the printouts and stuff. I don't do any of that anymore. And part of it is because the software's gotten better, but also it's filtered down into earlier grades and things. So virtually all of my students are very comfortable using the computer. Now this may be something with particular students that come into my courses and come to our school, but this isn't a big issue with computer phobia the way it was 5 or 10 years ago. I mean, I don't tell my students how you get on the network, how you get printouts, that sort of thing. They know you click on this button to close the application, you click on this button to open it. They're real good at much better than I am at a lot of things. And I'm not sure whether that's something that you're finding universally. But it's not nearly the same job it was 15 years ago, trying to get the students up to speed and using that and getting students. I mean, students are enthusiastic in most cases now about using most of this technology. Okay?
Well, with that in mind, I was going to say, maybe there's a comment that instead of technology can be expensive, I worry more about technology can widen the gap between the haves and have-nots. Because you went to a school, if you're in a good school where you have the computer network, and you have all that stuff in your dorm, you can do all this. And then be farther ahead, because then you know that technology. You know, it really snowballs. And if you get behind you, if somebody continuing at
There's the glitch.
Okay.
Yeah, I don't think we want to move this stuff here.
Okay. Sorry, would you try to see if you can get on, or are you going to use the network?
No.
Okay.
No,
so next question.
we're okay. We're okay for the.
Sorry about the.
Okay. When they crash computers in the open community, they crash computers. Okay. It's still there. There will be glitches. Okay. All right. A couple of things I pull back, and this is one of my favorite. In fact, this I think probably if we had an award for the most quoted statement about statistics education reform, this may be it. This was in a paper George Cobb wrote reflecting a discussion group. And one of the things, they had several recommendations. One was more data and concepts, less theory and recipes. I think that's probably about one of the most famous single lines to pull out on statistics education reform. And I want to see a little bit of how technology influences that. I'm going to sort of concentrate on data for a minute. Concepts, I know Rick's going to talk some about concepts in terms of randomization and things, and so he's going to get at some of that. I'm not going to talk quite as much about concepts. And I guess, Roxy, you're going to do some concept stuff also. So we will see from some of the later speakers some more about that. But I want to talk about more real data, and the more I want to make sure modifies in both directions here. So more real and more data. Okay, and I think this is one of the things that technology has really enabled us to do, is to get at lots of good real-world data. So things like textbook data sets. I would think if I was looking at textbooks to evaluate stuff, and if I saw a textbook which didn't have either a data diskette or a website where you can get the data sets or something like that, I would probably reject that immediately. If it doesn't have lots of data somewhere in a convenient electronic form, it's probably not as current as I'd like it to be, or as data emphasis as I'd like it to be. But there's usually now lots of good data sets that come in some sort of convenient form right along with the textbook. And I think that's important. Okay, data from the web. This is one of my favorite web uses. Oh, I guess David's going to get to talk about that more. So David's going to show a lot of these things tomorrow in terms of archives where you find data sets, places to search the web for data sets. Just the technology allows a lot more real data, and especially data that involves real situations. And go to Lori's talk tomorrow to see how to get real data out of current publications and media and stuff. Because there's lots more real data that's readily accessible that was never there in 1983.
I find it increasingly frustrating on the web, though, more and more data, they're digesting. It's hard to get them into the form.
So that you got to work some to get it?
No, where you get to select things and they will then give you a graph.
Okay.
Interfaces are
It's hard to get,
fancier, which is better for common users, but not for
but harder to get at the raw data. Yeah, I'm not sure, I haven't encountered that so much, but it's true that you're likely to see the, sort of the summary, executive summary before you get to see the raw data. But again, you always have the nice possibilities of being able to contact whoever has that data and get it in a nice form. The other thing is it's a lot easier now to handle bigger data sets. You don't need to restrict yourself to just 9 temperatures at a time. You can get big data sets with lots of variables, and you can transfer them back and forth electronically. I can't remember the last time I actually physically typed in my own large data set. I mean, almost anything now is cut and paste from somewhere else. Okay. And you can also get more meaningful projects. Okay, the kinds of projects I see where my students do things like find a data set and describe it, okay, they can get at more meaningful data than they could years and years ago. And just as an example, here was a very common, when I have this, find several variables and describe them in 1983, this is what I said. They go to the newspaper and they say columns of numbers, columns of numbers, columns of numbers, right? And they would quickly go to the sports page, and this is the top 10 hitters in the American League, and you've got several variables there, and you can do nice descriptive statistics on it. But you really want to know what the average batting average is for the top 10 hitters. Does that really tell you very much? Whereas now my students routinely go, and this is it's hard to see, it's a website where you only see part of it here. You see there's a lot, actually if you look over here at the arrow, there's lots of stuff coming in. There's a list there of every American leaguer who's had an at-bat during the year, at least one at-bat, and they're all there. Okay? And you can sort that list based on any of the variables across the top there. You can click on any individual players' names to find lots of other stats and stuff. There's just a ton of data sitting there at that one site. And that means my students have got to pay attention now to things like sampling issues. Right? They obviously can't use all of those players. They actually have to think about, well, how can I select a sample of those players? Do I keep the players with only 2 at-bats for the year? Okay? Or do I have some sort of cutoff for that? They really have to start thinking about how are they going to collect the data from that population. Okay? And when they get it, they get a lot more meaningful data. So if they want to see, do National League pitchers have more strikeouts than American League pitchers? Okay? They can actually do that in a much more reasonable framework, getting the data themselves than they could have years ago. Okay, back to the same recommendation. Let me go to the second part. Less theory and fewer recipes. How does that figure in? Here's an example. Correlation in 1983. What do you think correlation looks like in 1983? Think about if you're in 1983, what your student's image of correlation would be. Unfortunately, mine would probably be that. Right? There's the image of correlation. Right? I mean, talk about something that's totally non-informative. Right? Does that tell you anything at all about correlation? Right? Now, to a math geek, maybe it does. Right? But to a generic student, that tells you nothing at all about correlation. But that's what they would think of. When you would say calculate the correlation, if they're on the ball, that's the first thing that would come into their mind, is that formula. Okay? Which I think is pretty non-informative. Is the formula wrong? Oh, I need a square root down there, you're right. Okay. We'll skip past there. Okay, so now when you get your hand out, you have to find the missing slide and add the square root to the formula for the correlation. You can see how long this one's I looked at that. All right, what does correlation look like now? Any guesses what you would think correlation would look like now? What did you think of when you think correlation?
Lots of scatter plots.
Lots of scatter plots? Okay. Now my students probably think of that. Right? Now on the surface, is that a whole lot better? Right? I mean, they think of correlation as that key, where is it? Right about right? That's what they think of as correlation. That's not necessarily a whole lot better than that formula. But it does mean that they can calculate their own correlations much more efficiently, and they can calculate lots of them. And that's the only way I think that you can get much of a feel for correlation, is to look at lots of them. And that's what the technology lets them do. Okay, and Jason's going to talk some about correlation, I guess, coming up, so I hope I won't steal too much of his stuff. But here's the other way. Someone said lots of scatter plots. Now, this is the way I use correlation in my intro stat course. I actually don't show them this right away. What I show them is a selection of these. We usually start off and look at, this is 1993 car models. And if you came in here, this is weight versus median price. Okay, so show them that scatter plot, and then ask them what sort of relationship they would see, and then I'll do weight versus city miles per gallon. And they'll pretty much anticipate you should see a negative slope rather than a positive slope. And then I'll maybe do up here median price versus city miles per gallon. You see that nice kind of a curved structure there. And we'll play around, we'll pick out outliers. There's a Mercedes hanging around in here, which shows up as an zero point. So we'll sort of play around with those sort of things. And then ask them about median price versus maximum price. This is for a loaded model versus kind of an average number of outcomes. And they obviously see a nice strong association there. And then I'll often ask them about well, something like down here, the median price versus RPMs, when the engine's going at most efficient speed, how fast is it turning on. Okay? So we'll do several of those scatter plots and talk about the sort of relationships we're seeing. Okay? And then there's the idea of correlation, and go through and find the correlation for each of those scatter plots. You just have the software find the correlation for each one, and then I'll ask them, once they've seen the scatter plots and see this list of correlations, right? What are the properties of correlation? And they'll quickly tell me how the sign reflects the trend in the curve. Closer to 1 means one thing, closer to 0 means something else. They'll easily pick up on their own what the properties of correlation are from having gone through that. Okay? And then I may or may not show them this picture. Actually, this picture is nice. If you ever look at the way, for example, Minitab presents their correlation matrix, they just give you the lower triangle, which is just this information right here. Right? And once they've seen this picture, that makes a lot of sense to them, because you can see that's just the numerical version of what's in the lower triangle of this scatter plot matrix. Also, one other thing I find is useful for students is that confusion they have between correlation and slope. Okay? And you can look here at this scatter plot and look up here at this scatter plot and say, well, look, there's a much better slope there. I mean, that's a much steeper slope, a much stronger relationship. But of course, it's exactly the same variables. So it's exactly the same correlation. There's no stronger relationship in one or the other. And so that helps them get away from that notion that slope necessarily tells them something about strength of association when they see those two pictures.
Yeah, there's also, if you look at the top, on the right and the lower left, you see just the compression on the vertical axis. It gets rid of the striation in the lower left.
Mm-hmm.
The
Yeah.
expansion on
Oops.
the horizontal axis shows the striation.
Yeah, that's true. That's a good point. Yeah, because you can see, okay, comparing this one to that one there.
Yeah.
Right? Yeah, that's a good point. They really look like sort of different stories.
It does look like a different story.
Yeah.
Then you have to think of why.
Yeah, it's good. It's got a new one I can use next fall. Okay, what are we doing here? Click around. Okay, here's another way that my students will start thinking of correlation. There's a neat little app that's out there on the web where it presents 4 scatter plots. Okay, and you just have to match up the correlation of the scatter plot. And I picked a particularly easy one here, so we can probably all do that. Tomorrow when I talk some about web resources, we get to play this some in the lab. But I play this with my students. And it's kind of a fun game. We'll sit down, let them guess, and we'll sort of play through this a bunch of times. But the neat thing that doesn't show on here is that this particular website, as you do this, if you get to 4 right, it'll say, do you want to do 4 more? And it'll sort of keep the streak going. And what you don't see here is down on the bottom, there's a top 20 list for people worldwide, right, that have played this game, for who's got the longest streaks. And especially if you get there early in the semester when they sort of, I'm not sure how often they start that list over again. But if you get there early, it's actually fairly feasible. The first time I did it, you only need to get something like 50 in a row or something. So I said to the class, well, we'll play until we miss. And the whole class, we kept going on, and we'd sort of have big debates, because sometimes, this is a pretty easy one. Sometimes it's not nearly so clear. It'll have a 0.88 and 0.89 you've got to decide between. And so you just sort of guess. Anyway, but we made like 60 in a row And so we got live in class, got on the top 20 list for this game. We put in Matthew 13, St. Lunch University stuff. And they just thought this was really neat to do that. And so just as a, sort of a, I said, as we were doing it, I said, all right, if anybody else, if you get on the top 20 list, you get a free point in the next quiz. And this is 1 point out of 400 for the semester. They went bananas. I couldn't believe it. I was getting, phone messages at 2 in the morning saying, check the list as soon as you get in because I'm on there, but to be like number 19 and I'm afraid to get knocked out. And we're just going crazy. And of course, then they want to get on the top, and somebody else will get on, someone else in class will want to beat them, and they'll sort of go like this. You will see when you look tomorrow, you'll see the list. It gets pretty obnoxious after a while. People get on there. People get on multiple times. And in fact, one guy, I guess from University of Vermont, didn't you? University of Vermont? I don't offend anybody. But there was a student there who got on a whole bunch of times. His name was Jason, I think, and he kept signing his name. And finally, someone got on as like number 18 and signed their name as Get a Life, Jason. Right? I mean, how many students would spend 2 hours from midnight till 2 in the morning matching scatter plots with correlations? I mean, this is, I think, where you're getting into the Nintendo mentality of some of the students. I think it's just a great game. But certainly they do, and that's really what I want them to get. When I want them to think correlation, I want them to think an association with the scatter plot. That's the image I want them to have for correlations. Okay, one of the recommendations from George's paper was to foster active learning. And I know we've got several people that are going to talk to us. Bob's going to talk some about active learning, and Laura, you're going to do some active learning type things also, right? So I think we'll get to hear some more things. And that's one of the things technology has really helped us do, is get a lot more interactivity into our class sessions. And so in-class data collection and analysis. Okay? And I guess you're going to talk some about that sort of thing. I mean, that's a big change. I remember in the old days I used to have a calculator, and we'd want to do any kind of in-class data collection. I would pass the calculator around the classroom. And by the end of the class, it would have reappeared back at the front, and I could say, here's the mean, here's the standard deviation. And it's a whole lot nicer to be able to do that with software now, and do that live in class and let them see the results and do graphics and play with those. Okay. Lots of simulations. Okay. It's a whole lot easier to do simulations now where they can have some input into that process. Some with technology and some without. I'll tell you, for example, the way I introduce sampling distributions. I do it for proportions first rather than means. And what I do is I say, well, we're going to find out, let's assume that initiating variable is a proportion of students at St. Lawrence that are firstborns, oldest children in their family. Any idea what proportion of your students are firstborns? It probably varies a lot from school to school. Any idea what proportion of students are either only child or oldest? Okay, someone said 40%. That's about what it tends to be for my students. It probably varies a lot depending on the situation. It actually is also not necessarily an easy question to answer now. As families reconfigure in various ways, it's hard to say whether they're the oldest anymore or not. But I use about 40%, and we collect that from them and find that. So I said, well, suppose that is the population for St. Lawrence students. 40% is the proportion. And so then we want to go along and take a sample of 50 students. Right? We're going to take a sample of 50 students. What proportion of that sample should be firstborns, if it is 40% of the entire population? That's the way I get at sampling distributions. And we do it, first of all, just from a random number table. I give them a random number table, and everyone gets a row in the random number table. I say 1s, 2s, 3s, and 4s are firstborns. So that's 40%. Everybody else are older. And so we run them that way, and each student takes a row, finds a proportion in their row, calls it off, and we sort of do some multitasking. And then I have one student drawing a dot plot, and I'm putting the data in the computer, and someone else is writing down the results. But they can sort of hear what the proportions are as we go through each one. Okay, and then we put in the software, we can find the mean, we can find the standard deviation, we can look at the distribution, and then I'll have something like Minitab re-simulate that again for lots more samples and see what things change and what things don't, and change the sample size and see what things change and what things don't. Okay, and so that's kind of a good way to interface that technology, because it has the students actually starting the simulation themselves, but then it lets the computer take over to do the lots of cases you need to be able to see the picture well. Okay? And so that's why I think that level of interaction is very useful. Live what ifs. And that's my argument for having this stuff live in the classroom, is when some student says, what happens when you take out the Mercedes? Let's see. Okay? There's lots of good applets now that do this. Let you take a scatter plot and pick a point and move it around, and watch how the line changes as you move the point around. Okay, and there's a lot of real good things that get across concepts real quickly as you do that. Okay, dynamic graphics, same idea. You can really get to see things a lot better as you let graphs move. Okay, and certainly, Gary, you've got lots of good kind of moving graphs, I know, and stuff that you do that helps you see things. Okay, hyperlinked text. Okay, a lot of the online textbooks and things like that will let you jump to the definition right when you need to. Okay, and my favorite are just various, I think what Paul Vellman in ActiveStats calls toys. Right? Toys and applets. Okay, just little things you can play with, like the correlation guessing game. One of my favorite ones that's in ActiveStats, which I don't use, but I would like to sometime, is the thing comes out fairly early where the student's presented with a little game that says, you're going to see a circle on the screen. Anyone here used ActiveStats? Okay, so you may have some experience with it. You're going to see a circle on the screen, and click as fast as you can in the middle of that circle. And this is practice a few times. If you practice a few, these circles appear at random places around the screen, different colors, different sizes, and you click, and the next circle appears as soon as you click, and you have to move and get that one. So it's okay, once you practice this, now do 20 circles as fast as you can. Okay, so 20 circles are presented as fast as you can, you click in the center of each of them. Okay? And then the real kicker that says, now put the mouse in your other hand. Okay, and you can imagine the reaction right away. If any of you try to use your offhand for a mouse, and do it again. Okay, so run 20 more in your other hand. And then it automatically generates a data set, which keeps track of the color of the circle, the size of the circle, how long in milliseconds it took you to get to it, how far you were from the center, okay, which hand you used, and that data set's instantly created and loaded in the software. Okay, and this is something to do right away, early on in that software. And it's just a wonderful sort of game, because of course what students want to do right away is, I've had a few of them try this, right? They want to go back and do it again, see if they can beat their time. It gets to be a real competitive type thing again. But those sort of games and toys that can liven up things a lot, and really get students hooked on doing that. Okay, so looks like 10:30 I'm supposed to quit. So what's next? Okay, and this is actually meant in a couple of ways. As David indicated, tomorrow afternoon I'm going to talk some about where things might be going. But I think we'll see that a lot as we go through the other sessions here. And I'm really excited about seeing some of the other speakers here. I think you're going to find out there a lot of what's next, what things are coming down the road in ways of technology, and ways of using technology and stuff. And so,
What do you use PowerPoint, or what do you use to generate these?
PowerPoint. Okay. So I think that what's next is a very interesting question in terms of both what else is going to happen for the next day. In the intro course, we have projection facilities in the classroom, so I do lots of demo for them. So they get to see a lot of this stuff, but they aren't actually hitting the keys at the same time. And then usually early in the semester, I'll schedule open lab times where I'll say I'll be there between 1 and 3. Anyone who wants to come in can come in, and we'll just play with things. And then once they get that, they're really on their own. And I haven't experienced much difficulty at all. Occasionally, I'll have students say they wish they could, have the whole class in the lab because they want to be able to, play Tetris or something along those lines. Right? That's one of the disadvantages, by the way, in those machines that are nice and flat. It's hard for me to tell what they're doing. What I really want, some of you may know if the software does it, what I want is something in the instructor station has a grid with all 24 machines on it, and a little icon of what each machine is doing. And I'm serious. Partially so they can't play games then, but partially so I can know whether, when I'm using that class, and whether or not they're on the same page or not, or if someone's well behind me. And that's one of the drawbacks, is it's hard to see where everyone is. Of course, if the monitors are facing them and they're facing me, it's hard to see anyway. So I will schedule some time where I'll be in there. But after that, it's mostly demonstration in the classroom. Yeah.
Do you have assignments where they have to use the lab in order to do the assignment?
Yeah, things like the project.
But just the sort of project?
Projects and that sort of thing. And there's various times we'll have homework problems, which will require, have 200 data cases or something, and they're welcome to do that all on their calculator if they want, but they would probably prefer to do that, and I'll have that data available in the class directory and stuff in the and use it there. So there are homework problems. Usually those aren't ones that have to be turned in too much. The other thing I can't do as much as I'd like to in this class is have them actually use the software in a test type situation. I could do that in the upper level courses because they're small enough to go in there. So typically in like the second stack course that we have, I'll do things like when we have an exam coming up, I'll give them the data the weekend before the exam and say, you can probably guess what the questions are going to be, but you can play all you want with the data for this week, and after that will be on the exam, and then they'll do it live in class. But it's harder to do that with the bigger group. What?
When the advanced placement in calculus came along, it wasn't too hard because the calculus course was pretty much the calculus course. But now there's such differences in the basic statistics course. How are you going to decide if somebody has an advanced placement whether to skip that course?
Yeah, and certainly my sense is, and that's one of the reasons we've been developing a follow-up course. We've got what's essentially a regression linear models type course that follows the intro course now. And that would be where I'd want to send someone who came through the AP Stat course successfully. There's a lot who go through that who still can benefit from doing the intro course again. But for the ones who really come through the AP Stat course successfully, that's where we want to have that second course available for them to go to. Yeah.
On that monitor, what are they doing? I have seen a situation where not only the grid do you see what they're doing, but you can cut off the monitor, and you have to watch the screen, or you can take their monitor and project it on the screen.
Yeah, that's good. I'll talk about what that may be, because that's the kind of...
No, if they have a problem, where they have a problem, then you can't discuss that with everybody individually, but when they can project it up on the screen, then the class can discuss it, or you can discuss it.
Yeah.
So the whole class can see what the problem is.
No, and that's good. And that's a good point, because a lot of times I'll do simulations where each student will be generating a different sample, and then I'll have someone write a particularly interesting result, and that would be a nice way to be able to show everybody else, well, yours looks like this, but someone else who sampled the same population got this. So that's a good.
Metro Stadium, St. Paul. So,
That would be a good thing to find out about. Anyone knows about using this kind of system?
I'm going to talk a little bit about it in a second.
Okay, good. I knew I was leading into something.
I think we have time for one more here.
Does the textbook that you use exclude the topics that you do not cover?
Does it exclude the topics that I cover? Most. I use David Moore's Basic Practice Statistics, and that has relatively minimal probability treatment. There's a few things that are in there as optional sections, but mostly it's, I don't think there's too much that I have to worry about that way. And in most cases, they're sort of buried by themselves, so I can just jump over one section as I need to.
I think we're going to cut it off if we could now, and thank you, Robin. My brain is not full, but it's riding off in a dozen different directions, and I'm looking forward to, and we can get those.
Remember the quiz is, put your square root on that formula, and then figure out which thing on here didn't show up on.